Hi everyone, welcome to PhDizzle. I'm your host, Alice Cheng, and today we're interviewing Roo Vandegrift, who got his BS in biology from Virginia Tech and his PhD in mycology from the University of Oregon, and is currently a postdoc with the University of Oregon and also working on a very cool project that we'll talk about a little bit later as well. How did you get into science and research, and what inspired you to do your PhD?
Yeah, well, so like you said, I did my undergraduate at Virginia Tech, so the background there is I'm from Virginia, from that part of Virginia in the mountains. So I have, we'd say I'm Appalachian, I guess, and so I'm one of the first people in my family to go to college. Me and my older brother both went to college, and then I'm the only person in my family with a PhD at this point.
Wow.
So we grew up poor, like pretty significantly below the poverty line. My father joined the Air Force to be able to sort of support the family once it became obvious that there was going to be a family to support. We went from when I was born, we went to Greece, we went to England, we went to Alaska. All over. And then eventually my father took an early retirement and settled back on the family plot of land in the mountains of Virginia. And so when I was an undergraduate, I was one of those like high achieving, I got all A's in school because it was a way that I validated myself. I think like a lot of kids, the highest academic achievement is held up as medical school.
Yeah.
And so I started out thinking I wanted to go to medical school. I was poor, right? So I worked generally about 40 hours a week through my entirety of my undergraduate. I paid my own way through.
Wow, in addition to school, you also worked 40 hours?
In addition to school, I worked about 40 hours
Wow.
a week. And so wherever possible, I tried really hard to find paid work that was in biology in some way. And so I ended up getting a job in this soil ecology laboratory, Dr. Robert Jones, where he hired me as an undergraduate and paid me very well for the time period. The other job that paid relatively well was nude modeling for the art department.
Whoa.
Also fun.
That's a thing. I did not know that.
Well,
cool.
They pay their models well. And I was interested in art, so it was nice. It was a way to get to sit in on some art classes and get paid for it, right? Finished my undergraduate, and I worked for a couple of years at a biotech startup company called Intrexon, which had offices in Philadelphia. So it took me to Philadelphia. And there I ended up getting to know a whole bunch of people who had medical degrees. A woman named Anya Trakyukova was my boss. And she had a PhD in molecular biology, I think. And she basically was like, you don't really want to go to graduate school. And she's very stern. She's a very small, stern Russian lady. She's like, you don't want to go to medical school. And it was this realization moment where it's like you don't get to really ask the questions with a medical degree. You're problem solving, but in a way that's really different from science. Doctors don't do science. Doctors take science and then they apply it to particular situations. And that was something that I think, I must have always known, but I'd never really thought about. Yeah. And so by the time I finished with that startup company, which was, its own saga of startup funding, boom, bust, by the time that was over, I realized I didn't really want a medical degree because I just worked with a whole bunch of people who had medical degrees. They'd gone into this startup world because it was a way that they could do research, but still be able to finance their medical school debt. Whereas a lot of them would have rather been doing, university or nonprofit work. But instead they're in this crazy for-profit environment because they have hundreds of thousands of dollars of debt. I was like, I don't really want that. I started working as a technician in a soil ecology lab at University of Pennsylvania with Brenda Casper, working with arbuscular mycorrhizal fungi, AMF, which are fascinating, ancient symbioses, go all the way back to, the colonization of land by plants in the Devonian era. And it really cemented in my mind, I should go get my PhD specifically to study symbiosis. What got me interested in fungi was the ecological concept of symbiosis, the way things work together.
I'm going to interrupt because this is an ignorant question, but is it fungi like with a J, or is it fungi with the G? Because I've always pronounced it the other way. Or is there some sort of differentiation based on what you're talking about?
Latin is a dead language. You can pronounce it however you want. Fungi is more of a European variant, and fungi is more of the American variant.
Well, the other thing I learned just today, right now, is that mycology is the study of fungi, and that is what you got your PhD in. So how did you, I guess you talked about symbiosis. So how did you decide to go into this particular field? Like, what was so interesting, and how did you pick your lab?
Like I said, I was interested in symbiosis, and I was working with Brenda Casper at the University of Pennsylvania with these arbuscular mycorrhizal fungi. And my initial thought was that I wanted to put together this fascination with arbuscular mycorrhizal fungi in the soils. And so that's this, this nutrient symbiosis. The fungi provide nutrition and water to the plant, and the plant provides photosynthate. They provide the food to the fungus, and they coexist that way. And so that's fascinating, and it's foundational. 90% of plants have mycorrhizal symbioses. And so I thought, I should take this symbiosis. And then there was another scientific concept that I had learned about as an undergraduate that was super fascinating to me, is the idea of fire ecology. So when I was an undergraduate, I did a summer, and this is, again, my quest to find biology jobs that paid. I spent a summer in North Carolina with the Sandhills Ecological Institute doing work with this endangered species of woodpecker called the red-cockaded woodpecker. What's interesting about these birds is they live in this ecosystem in coastal, like the Piedmont area of North Carolina and south, called the longleaf pine savannas. Longleaf pines are fire-dependent trees. And in a natural system, that ecosystem has low-intensity ground fires almost every year. Really regular burn cycle. Keeps the undergrowth clear. The trees are spaced really widely apart. Regular fires keep the undergrowth clear. And that habitat is perfect for these woodpeckers, which are the only bird that drills cavities into living trees. So you get this forest that's dominated by these widely spaced pine trees. And because there's regular fires, there's no standing dead wood, right? So anything, owls, squirrels, flying squirrels, other woodpeckers, anything that nests in a cavity depends on the cavities that are drilled out by the red-cockaded woodpecker. So they're a keystone species. And there's only a few hundred of them left at that point because of fire suppression. People don't like fire because it burns houses down. But when you suppress fire in these ecosystems, you get like this shrubby understory that grows up in between the trees, and the woodpeckers, they can't tolerate that. It changes their habitat, so they fly off in search of better habitat, which no longer exists. So they're in danger of extinction because of habitat destruction by way of fire suppression.
And then all the other animals don't have a place to live either then.
Exactly. And so it becomes like, this cascading effect. And so when I started looking at graduate schools, I was really interested in combining the idea of looking at like fungal symbioses and fire and like the way these things interact. And so I started looking at labs around the country that worked on both of those things. And the lab I landed in at the University of Oregon, Dr. Biddy Roy's lab, worked on both of those things, but not together. So she worked on fungal symbioses and she worked on some fire ecology. And I thought, I can come into this lab and put the two things together, which was the initial plan. Well, I ended up working on fungal symbioses, but not mycorrhizal fungi. I ended up working on endophytic symbioses. So
what does that mean?
Unpack it. So endo, right? Endo means inside, and phyte is for plant. So endophyte, inside plants. And so just like humans have a microbiome, right? So we all have thousands of species of bacteria living symbiotically with us, like in our guts, inside, on our skin. You can't get away from it. Plants also have a microbiome. And so plants have hundreds or dozens of species of fungi living symbiotically inside of every green leaf. And those are endophytes. They don't cause disease, they don't hurt the plant, they're just the microbiome of the plant. My advisor, Dr. Biddy Roy, shared her lab with an emeritus professor, a retired professor named Dr. George Carroll, who became my second dissertation mentor. George Carroll, turns out, was the person who discovered endophytes in the 1960s.
Wow.
He had this idea from a long time ago that he called the foraging ascomycete hypothesis. So ascomycetes being it used to be a class, but is now a phylum of fungi, the Ascomycota. And the basic idea was that one of the possible reasons that a fungi might be an endophyte inside of a leaf is as a foraging strategy. I ended up studying the genus Xylaria, which is dead man's fingers or candle snuff fungus. So you've probably seen them. If you ever see a big chunk of wood and you've got little black finger-like fungi growing on them. They're common endophytes, like ubiquitous. And the answer does seem to be this dispersal thing. And the easiest way to explain it is think about a mushroom, right? Makes a whole bunch of spores, millions and millions of spores for a very short time period, right? So we have a dispersal strategy that is high density, short duration, right? If some of those spores end up causing endophytic infections in the leaves and the canopy, they stay there, low metabolic cost, they just basically hang out until the leaf is shed. And then the fungus rides the leaf down like a lifeboat. So in tropical forests, which is mostly where I work, you can, the average lifespan of a leaf on a tree is about 2.5 years. The
wow,
leaves
because
right?
it doesn't
season.
snow. Okay, right.
Exactly, right? So the leaves are shed when they're no longer photosynthetically productive for the plant. So, you've got all these endophyte infections, and just like every now and again a leaf comes down. Every now and again a leaf comes down. So you go from a short duration, high density dispersal strategy, the mushroom, to a really long duration, 2.5 years, but very low density dispersal strategy. So there's a diversification of dispersal strategies. And so we've now published 3 different papers showing evidence for that particular lifestyle for the genus Xylaria.
So that work took you down to Ecuador, or what other place?
Ecuador.
Okay.
Yeah, Ecuador, and the other place I've worked on that kind of stuff is in Taiwan.
Oh, interesting.
Yeah.
I guess Taiwan does have, they're pretty fair year round, right? Or do they?
It's subtropical. It's kind of like Florida.
While you're in Ecuador, also, I guess you've become passionate about a topic area that's on a much larger scale. So can you talk a little bit about that and what the project is that you're working on?
What you're alluding to is conservation work.
Yeah.
And there's lots of different ways that my research has fit into conservation frameworks. Right now I'm producing a documentary film. And so a little bit of backstory. I work at a protected forest in Ecuador called Reserva Los Cedros. It protects the sources of 4 rivers, and it has, I think there are something like 225 known endangered species within the reserve, including jaguars, Andean spectacle bears, the brown-headed spider monkey, which is the most endangered primate in all of Ecuador and one of the most endangered primates in the world. So it's a very special place. And it's within this ecosystem called the choco. The choco ecosystem extends from southern Central America down the western slope of the Andes to Ecuador. And in Ecuador, it's been severely deforested. There's only about 3 or 4% of Ecuadorian choco left. And Los Cedros is some of the last of it. So it's a really great place to do research. It's really beautiful, it's incredible. And in 2017, 2/3 of it were granted in mining concessions to a Canadian mining company called Cornerstone Capital Resources. And so that was a big wake-up call. This reserve has always been threatened. There's always been conservation concern. But this change in policy from the Ecuadorian government just blanket said bosques protectores no son áreas protegidos. So the protected forests are not protected areas. And that's a direct quote from an agent of the Ministry of the Environment in Ecuador. So overnight, 30% of the network of protected forests across Ecuador was now under threat of mining. And they sold mining concessions without any kind of consultation or consent from the people that were affected across the country. 300% increase in the amount of land area available to mining overnight. And so being a scientist, I said, well, what can I do? I can do science. And so I applied for some funding from the National Geographic Society on the basis of this urgent need to document the biodiversity at Los Cedros before it was potentially wiped out by a mine. We organized what we called the Richer Than Gold biodiversity expedition. Something like 20 researchers, American and Ecuadorian, from 6 different institutions, including the University of Oregon, ESF in New York, Universidad San Francisco de Quito, Católica, the Catholic University in Ecuador. We used the trail that had been cut illegally by the mining company deep into the reserve, and we camped at a site that was cleared by the mining company illegally for a month in the pouring. It rained. We were there for a month, and it rained a meter.
Oh my gosh.
You can imagine. So everything's mud. It's just pouring rain all the time. It was a really incredible experience. Some of the most difficult field work I've ever done. And we thought, well, we should probably document this because that could be important. And so we earmarked some of that funding to go towards documentation. I asked around a little bit, and it turned out one of my good friends was a filmmaker. So, well, hey, Dylan, you wanna come and run the camera for this crazy expedition we're planning? And Dylan starts talking to people, and it's like, oh, you know what? Just documenting this scientific expedition is not enough. And so Dylan started doing a little bit of planning, and then we reached out to our network of colleagues in Ecuador, and it's like, it would be really great to have an Ecuadorian filmmaker to collaborate. So Solange Yepes is an environmental communicator from Quito in Ecuador, and she's co-director. And then Antoniello Carrasco, who's also from Ecuador, from Quito, is the director of photography and the editor for the film. And then Dylan came back to me and was like, well, Roo, we really need a producer. I was like, oh, okay, fine. I guess I'll produce this documentary.
But what is a producer? What do you do? It's so cool.
Being a producer on a movie is kind of analogous to being the PI in a research lab, right? I'm responsible for fundraising, messaging, a lot of the story of the film, what is the story we're telling, making sure everybody else stays on task. Story in Ecuador has very particular villains. Cornerstone Capital Resources, Canadian mining company, owns the concessions for Reserva Los Cedros in cooperation with the Ecuadorian state mining company, INAMI. They initially began sending people into the reserve. They cut new trails. They cleared land for mining prospecting, which is absolutely illegal based on the law that establishes bosques protectores as protected forests. When Los Cedros sued the mining company and the government over this conduct, they won in court, in the provincial court in Imbabura last year. The ruling was that Cornerstone had not done proper consultation. They hadn't talked with the communities who depend on the clean water from the rivers that Los Cedros protects. And the court ordered them to stop all activities in those concessions and stripped them of their permits to be able to work. The mining companies continued to work despite this, saying and spreading the rumor amongst the communities that, they need a ruling from the highest court, from the constitutional court, for that to really take effect, which is absolutely untrue. The company has no permits right now.
But nobody knows, right? Because they're dealing with people who don't have that educational background.
Yeah, and so the case is going to the Constitutional Court. We actually just earlier this week filed an amicus brief based on our documentation of more than 225 species of endangered species within Los Cedros, and and various other. There was a petition to scientists that was circulated in August. That was signed by 1,200 scientists calling for the immediate protection of Los Cedros, including Jane Goodall and E.O. Wilson. But the mining company just announced that they're going to start drilling in Los Cedros. They aren't listening, and the government in Ecuador, the administration, Lenin Moreno's government wants mining to go forward. And since the pandemic has begun, they're pushing mining as the solution to the economic woes that have been caused by the pandemic. And so, it's like, who would enforce the revocation of these environmental permits?
Well, but
the government.
Does that money go back does that go back to the people? I mean, I don't think, like, the economy, that's like an interesting definition. It's
the reflection of the same thing that's happening here in the US, right? Like, we have a government in power that is looking at the stock market as economic indicators and saying, oh, everything's fine, the stock market's booming. Meanwhile, 30% of Americans are unemployed. People can't buy food. The number of uninsured people is skyrocketing because of protections from the Affordable Care Act are aging out. By what means can you say that, like, we're doing fine?
Yeah.
Most people are not doing fine. The rich people are doing fine. Yeah. It's the same thing in Ecuador.
So how are you guys fundraising? Like, how are you paying for it?
So a couple of different things. Like I said, we've got some nonprofit sponsors and partners. The biggest one being the Rainforest Information Center, which is an Australian rainforest conservation nonprofit. So they've been an incredible support, and they were instrumental in helping found Los Cedros back in the late 80s as well. We're also working with Mining Watch Canada. In Ecuador, we're working with OMASNE, which is the English, it's the Observatory for Mining and the Environment in Northern Ecuador. There's like another mining watchdog. And crowdfunding. So we, last year, for our return shoot, to go back and film more in Ecuador, we had a really successful Kickstarter campaign. We raised $16,000 on Kickstarter last year. And then right now, we're currently running our second Kickstarter campaign. And that'll fund returning to Ecuador to finish filming because we were interrupted by the pandemic.
Given COVID and stuff, but how much more do you have to do? Like, when do you think this will be ready for release?
Optimistically, we'll have a rough cut ready for the kind of things you do with a rough cut, which is, the initial shopping to festivals and things by summer 2021.
Summer 2021 is not that far in the future, but even so, is it still timely enough to be able to do something about what's happening there?
Mining in Ecuador will be an issue as long as people are greedy, basically. Yeah. The average time span to go from initial exploration to the commissioning and opening of a mine is 7 to 8 years.
Oh, okay.
And so, so these concessions were announced in early 2017. So, like I said, Cornerstone in Los Cedros has done 2 years of initial prospecting now, and they're just announcing that they're going to start drilling for advanced exploration. So if they start drilling, that's bad, because to start drilling, they have to bring in really heavy equipment, which means they have to turn these footpaths that they built, which was terrible anyway, but they have to turn those into roads that you can get heavy equipment down. And opening roads into these pristine protected forests is about the worst thing you can do for their conservation, because it allows access to that habitat for poaching, for logging, for settlement. And the Ecuadorian government has shown time and again through their history that they respond to external international pressure. I told you about this expedition. What we ended up doing was focusing on 3 main characters. Elisa Levy, who's the research coordinator for Los Cedros. So she represents kind of science and and Los Cedros. Isabel Anangono, who's an Afro-Ecuadorian farmer. So she's representing kind of campesina, the farmers. And then Filomena Rosado. Filomena is a leader in the indigenous Awa group. We've got these 3 women. They're representing 3 different segments of Ecuadorian society, 3 different ways of life, and 3 different locations within northern Ecuador. The plot is really about the science of mining and the science of biodiversity. And this expedition to the heart of the rainforest is very much at the center of this film, where the rainforest itself serves as an additional character. It's like you can develop the character of the forest through these interviews with people who interact with it.
Sounds like you have this artistic creative talent. So besides the scientific part of what you do, what are the other things that you enjoy doing in your free
Art has always followed me as something that like it's part of my practice to stay sane. It's very meditative, and of course it overlaps with my science. I do technical scientific illustrations for new species that we describe. But then I also really enjoy like more abstracted and surrealistic art. And lately I've been spending a lot of time doing repeating patterns has been a fascination for me, particularly during the quarantine. We were stuck for almost 2 months. We couldn't leave the house at all in Ecuador. So I did a bunch of these patterns.
Oh, is it all like biology based?
It's all biology based. And so this one, so like I said, I got my start working with arbuscular mycorrhizal fungi. They grow inside of the plant cells. And so here, this is a herringbone pattern, which is a traditional fabric pattern. Each square is like a plant cell. And then you have these structures. These are vesicles, which are nutrient storage devices, hyphae, and then these tree-like structures are called arbuscules. This is why it's arbuscular mycorrhizal fungi. And these are the nutrient exchange structures. The AMF hyphae pushes through the plant cell wall and then divides out into these highly branched structures, which provide incredible surface area where the plant cell membrane and the fungal cell membrane are in contact. I really love this kind of like kitschy 60s and 70s. Yep. The first thing I'm working on putting together a spoonflower shop. Spoonflower.com they do print-on-demand fabrics, mostly for the quilting community. My grandmother was an avid quilter, is how I learned about this. And so you can go on to Spoonflower and you can find any pattern that you could possibly imagine.
Wow.
But there are very few fungal patterns. I think there should be more. This is another traditional, just like the herringbone with the mycorrhizae. This is a traditional fabric pattern called a houndstooth. And so if you imagine each of these shapes in just straight black and straight white, but each of the little black areas is composed of a pile of different spores. And so we have alternaria here, we have cladosporium here, xylaria here, and a rusculoid spore here. This is a lentinus, or it's inspired by lentinus. Morels, I've always been fascinated with the shape of morels.
That's a type of fungi.
Mm-hmm. Morels are an edible fungi that's often collected in the spring. Netted stinkhorns are another sort of fascinating form.
This actually looked like children. Before you clicked on it, because I was looking at it from far away, it looks like a little girl with a dress.
It kind of, and that was the goal. It's often called the holy veil mushroom because they have this veil that's full of holes, and when it's mature, it's covered in a goopy spore-laden substance that insects come and they eat. This is probably one of the favorites for people on the internet because these are psilocybe. These are the psychedelic mushrooms.
Oh.
I'm fond of this one just because of the radial symmetry. These are geastrum, the kind of puffball, which have these really beautiful flower-like shape, and then amanitas, which have a very distinct veil here. This will be one of the first ones up on the Spoonflower shop. This is a Phylotopsis, which is kind of like an oyster mushroom.
Yeah, because this one doesn't even look like a mushroom. This is just like a cool pattern.
Right. My favorite ideas in patterns are where the repeat is like kind of hard to find.
Yeah, it's not like obvious.
The same as this. Yeah. Same thing with this one. These little flamellulas. Yeah. My personal favorites are paisleys. I've been obsessed with paisley for a long time. I don't know if you can see on my tattoo is also fungal paisley.
Oh, really? That's awesome.
We can get close to the camera.
Oh, I see it. Oh, cool.
Yeah. So I designed that. That was my PhD graduation present to myself, was a fungal paisley tattoo. and this is a different pattern. But yeah, and so there's like lots of every element is generally microscopic fungal structures or some this lichen here and the mushroom. Just to do a little writing, and so my partner and I have been writing slowly a sci-fi like radio drama podcast.
Oh my gosh!
It's about a guy named Nate who's stuck by himself in a little escape pod. And one day we'll release. It's been slow going since we're both so busy, but it is really fun. And so my partner plays the astronaut Nate, and I play the computer, which is kind of like a sarcastic computer.
Yeah, well, you can make it into a film now that you're a producer.
Yeah. So I play with sci-fi.
Cool.
The same ideas. There's Nate in the window, and one of the gimmicks for the podcast, the plan is that every episode is like a different he's like telling the same story, but it's different every time. And so every piece of art for it is a different escape pod, but the same character inside. This is actually going to end up being the cover art for a heavy metal album from some friends of mine.
Oh my God, that's cool.
So there's a band called Metarse. They're based in the Pacific Northwest here. It's instrumental kind of doom metal.
Wow.
And their new EP is going to be a cassette tape with this as the cover art.
PhDizzle.
Having fun with smart people who do cool things.